I'll be talking about security, about developers, and about the bloody users, and sometimes about the bloody developers, and sometimes about the bloody developers of the tools that all the developers have to use, but don't like using if they had a choice, but they don't have. It'll be about security, but let's start with something completely different. It's mid-January, 2 years ago, you're in Hawaii. You're enjoying the sun, the beach, the weather, great time, and now suddenly, 8:03 in the morning, something happens. Everyone's phone beeps at the same time, and everyone gets a message, the same one, saying, emergency alert, missile threat inbound to Hawaii, seek immediate shelter. This is not a drill. Now everyone looks at the message, and then for 38 following minutes, something happens. I won't go into details. You can probably imagine what would happen if you were on the beach and got a text like this. Then after the mentioned 38 minutes, the Hawaii administration finally managed to get to the inhabitants that there is no missile alert and that it was just in error and it was a false alarm. Everyone was relieved and nobody was particularly happy about such false alarms happening. And I mean, you could probably blame the operators of the alarm system that they are careless, that they didn't think about their work, or whatever you could think about. But the thing is that the alarm system has the user interface that looks something like this. And these are the possibilities that you can issue basically island-wide. And the thing is that the operator was supposed to do a regular drill that takes place every once in a month. And he chose the selection that is displayed at the top, the PACOM CDW state only, which is the red alert, while he was supposed to pick the one that's highlighted below, the drill PACOM demo state only, which is totally different, and there's totally no confirmation dialog in the meantime, and he just accidentally issued the red alert over the whole of Hawaii. And it's debatable whether it's actually the mistake of the operator or the mistake of the designers of the user interface, because the user interface is just not usable, and these errors are just so easy to happen. If there was a confirmation dialog, do you really want to inform everyone on Hawaii that the situation is really bad? He would have noticed what happened, and it wouldn't take 38 shocking, panicky minutes for everyone to find out that nothing really happened. You may say, yes, bad user interface. This is nothing to do with security, and I told you that I'm going to talk about security. Well, have you ever heard of encrypted email that's totally usable and totally secure and everyone knows how to use it? And I mean, academia has noticed it as well, that the encrypted email isn't of the best. And there are plenty of other usability drawbacks in security. Our focus, we decided our focus to be working with certificates. There are two main reasons. Certificates are basically ubiquitous. Think about TLS. Every major website now is HTTPS secured. Secondly, TLS API is notoriously complicated. There are very famous or infamous mistakes done at corporations. There are many academic studies on the API drawbacks, and there was even a paper that claimed validating SSL certificates with a custom code as being the most dangerous code in the world. The paper is, by the way, very good if you're inclined to reading stuff like that. So we decided to do an experiment and to find out whether people visiting Brno, the developers, the students, and the IT professionals, what's their stand and what's their status? Are they able to work with the tools? So on DevConf 2017, we set up a research booth. We invited users to come and perform a simple task. Their aim was to generate a self-signed certificate using OpenSSL and to validate 4 certificates by OpenSSL that they were given. Basically, coming from the idea that OpenSSL is by far the most used library for certificate handling. And the results were somewhat complicated because 87% of the users thought that they succeeded in the tasks, while only 45% of them actually did. So they weren't even able to get from the outputs or the error messages that there is an error and that they didn't succeed. We found out that the default arguments in the OpenSSL command line interface matter a lot, and some of them are very well set. So most of the people, without knowing, generated quite secure keys because they were long enough, while elsewhere the default arguments basically fall behind. And again, many people, without knowing it, went with the insecure default. There were some further troubles with the manual pages, and we basically proposed some changes and managed to get 2 small patches into the upstream OpenSSL. So the main pages are a little bit better, and a couple of things the OpenSSL guys managed to improve in the meantime by themselves. We made an academic publication presented on our RSA 2018 in the US. Then we thought, what next? Well, let's go further. We know that errors are a problem, that people don't necessarily understand that an error occurred and that they didn't succeed. So we were interested whether they understand the error messages, whether they know what happened when a problem with certificate occurs, and whether the problem that they see is severe or just something that isn't ideal, but they can kind of live with that. So we decided to make a new experiment. A year later, DevConf 2018, we again set up a booth, as the previous one was quite successful. We had 70 to 80 participants again, seeing 5 different error messages regarding certificate validation. The certificate, one was expired, one had a host name that was mismatched, one had name constraints violated, another one was actually okay as a control case, trying to find out whether the users automatically wouldn't distrust everything that we give them just because we are saying it's an experiment. And we were interested in their understanding of the problem and in their perceived trust, whether they trust the problem, well, whether they trust the server with a certificate with such a problem, totally not, or a bit, or they would connect anyway, even though there's a problem because the problem is not severe. And the second thing that we had in the experiment was comparing the existing OpenSSL error messages with somewhat improved versions that we devised ourselves. So we looked into different documentation, different error messages, and iteratively we created a better version of the error message and the documentation for the 5 cases that we had. And for half of the participants, we have shown them the OpenSSL ones, the real ones, and for the other half, we gave them our design that we hoped to be better, to see whether the difference is measurable, whether it's actually better or worse, and where it goes. Regarding the results again, we found out that trust is far from binary, because in the ideal world, either the certificate validates and you trust it, or it doesn't for whatever reason and you don't trust it. However, there's quite a lot of developers going with I kind of trust that, and I mean, if this was Microsoft or Red Hat, it would be a problem because it's a big corporation, but if it's a bistro in the next street, I will probably connect and place my order anyway. So the world is much more complicated than the binary ideal that us, the security guys, would like to have. Secondly, some cases of the 5 that we presented them were rather overtrusted, and some were rather poorly understood. I mean, I understand that people don't trust expired certificates because they are expired, but they trust self-signed certificates the very same as they trust expired. Why? Literally anyone could create a self-signed certificate at any time. The expired certificates were okay and had value in them while they still were not expired, but the self-signed ones never did. You should never trust that. Regarding the redesigned documentation that I mentioned, we found out that in some cases it worked the same, and in multiple cases it worked much better, that either participants understood much more what the error was talking about, or that the error is more severe, that they would think about that. For example, in the case of the self-signed certificate, as I mentioned, our documentation was much better to get to the user that it's much more of a problem than just an expired certificate. Again, we did a small patch upstream. We had an academic publication on exec 2019, about 2 months ago. And again, we were thinking about where to go further. So now, knowing that errors are problematic and knowing what people understand or not understand and that we can do something about it because the documentation that we designed actually works better, we decided to kind of fix it, to try to improve the current situation so that we decided to consolidate and map the existing errors from multiple libraries. Basically, check up which libraries are used the most, libraries working with certificates. Take the documentation of all the possible certificate-related errors that they have, and match it in a way that this error from library A corresponds to that error from library B to that error from library C, which means that all 3 pieces of this documentation are basically about the same thing, though they are all written differently. And if we will be able to do the matching and to communicate with the developers then that this is the matching that exists there, and possibly we have a better formulation of the corresponding documentation for the particular issue, we can spare the developers time of writing up stuff, writing documentation, writing error messages that developers usually don't appreciate that much doing and writing and documenting. And we would create the world where the documentation of the errors is much more understandable and conveys the severity much better. And so we created a website, x509errors.org, that looks something like this and claims an attempt to make certificates errors more usable. It has the preliminary mapping table that's being constructed as these months. And then it has a list of all the error messages of OpenSSL, starting from OpenSSL as it's by far the most used tool. And for each of the errors, you can see by the different colored books that we already are assembling documentations from different libraries. And furthermore, for each of the errors, we want to provide an archive with a sample certificate that is automatically generated so that if you want to troubleshoot something, whether the errors and the possible things that can happen regarding certificates is working correctly, you can basically download all the different certificates, doing all the different errors that are possible in OpenSSL to find out whether your piece of software works correctly in all those different error cases. And then, since we don't know how to create the documentation that would be better suiting all the developers' needs, because we are a small team and not all the developers of the world, we again decided to do an experiment, asking the developers what would they want. And that's at DevConf 2020 experiment, again, setting up a research booth. By the way, you are all welcome. And asking for a better documentation, asking how long would they want the documentation to be, what would they like to be in it, whether it's more the description of what actually happened, or would the developers actually also appreciate an explicit paragraph stating what should be the next steps if you want to avoid or to resolve the sort of error? Are there differences between students and older, more experienced developers? Because then we can run the experiment on our students and the faculty and compare the results. Well, we'll see during the booth and hopefully with some of you on the booth and in the results. Before I finish, this all sounded like an ideal path from one experiment to the other, making sense, doing everything kind of fluently, which you can probably imagine wasn't the case. It was 4 years by now. So I'd like to pay kudos to all the people helping me, which is basically the lab people, the colleagues of mine and the advisor. Several people from the Red Hat group, mainly Milan, that's kind of partially university, partially Red Hat, and then people at DevConf who helped me to do basically now 3 research stands with all the support that was needed, and a multitude of students, because the research that I described was often a part of bachelor and master theses of students helping me do all the stuff in cooperation with DevConf, with Red Hat, with the lab of ours. So thank you to you all who helped me doing this, because I wouldn't be able in 4 years to manage such a feat. That closes the talk, and may your software be always usable and secure, ideally. Happy to meet you at DevConf.
Okay, fire up questions.
I'd be happy to take some.
He's not shy answering them, so go ahead.
How would you know?
I know.
The advisor of mine. Hugh.
So Martin, I know you're after a PhD for this. What do you anticipate the thesis looking like? Like, what sort of an argument would you try to make?
Well, I'd expect it to basically be a summary of the work on the usability of certificate validation from the early experiment, kind of as I suggested here. Ideally, if I could manage, with the end of, oh, and then we designed a better solution, offered it to developers, and the developers thought it was a nice idea, and we got some stuff changed in OpenSSL and in the actual products that are used, and now it's being upstreamed into releases. So that would be the ideal case for me. From the academic part, there has to be a couple of publications next to that. I have some, and hopefully there will be at least one more this year.
More questions? Then let's thank Martin again.